Science 8 Quarter 1 Week 1 Changes in the Motion of Objects Most Essential Learning Competency. Investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. An object may be acted upon by several forces whether object is at rest or in motion. An object may be pushed and pulled in different directions at the same time. For you to identify the forces which cause the change in the motion of an object, it is important to determine all the forces acting on the object. Examine the picture on the right side. Is the person moving? Yes or no? Why do you think? Motion is defined as a phenomenon in which an object changes its position over time. Motion is described in terms of displacement, distance, velocity, acceleration, speed, and time. In the previous picture, the bus shows motion with respect to its reference point from its place of origin. The bus moves with certain speed, at a rate by which it accelerates at specific time. With regards to the man, there is no motion as there is no change in his position nor displacement. What will happen to the man as he is standing still and the bus moves forward? How about when the bus suddenly stops? Dynamics is the study of forces that cause objects and systems to move. Force is simply defined as the push or a pull of an object with a specific magnitude and direction. The push or pull on an object can vary considerably in either magnitude or direction. There is a need for a standard force when representing a vector quantity, either push or pull. The man's body has inertia, and so a force is needed to change its velocity. The man's body moves backward as the bus moves forward. As the man holds on to the grip's handle, the force exerted by the bus through the handle makes the man's body. Law of inertia or Newton's first law of motion. The man standing still in the bus demonstrates the property of an object to resist any change in its state of motion. This is known as inertia. A body at rest remains at rest or, if in motion, remains in motion at constant velocity unless acted upon by a net external force. All objects have the tendency to resist changes in their state of motion or keep doing what the objects are doing. However, changing a body's state of motion depends on its inertia. A more massive object which has more inertia is more difficult to move from rest, slow down, speed up or change its direction. The car is easier to slow down from its motion than a heavy truck that is moving. The truck, which has a bigger inertia, is also more difficult to move from rest than a smaller vehicle. Which vehicle is more difficult to change its direction when moving, a car or a truck? When a moving bus suddenly stops, there will be change in motion. When objects are moving, eventually they will stop because of a force called friction. The law of inertia is often experienced when riding on a bus. Inertia is exhibited when the body moves forward as if to continue moving. Sudden acceleration will make the body move backward. This is the reason why there is a need to use seat belt. When driving, have you experienced this kind of motion when riding in a jeepney? Learning task number 1. Fill in the box with correct letters to complete the correct item being described. Number 1. The scientist who formulated the laws of motion. What is the correct answer? The answer is Newton. Number 2. The force needed to stop an object in motion. What is the correct answer? The answer is friction. Number 3. The property of an object that resists change in its state of motion. What is the correct answer? The answer is inertia. Number 4. The state of an object where the sum of all the forces acting on the object is 0. This shows that both the size and direction of the forces acting on the object are exactly balanced. What is the correct answer? Is equilibrium. Number 5. The body will remain at rest or move at constant velocity unless acted upon by an external net force or unbalanced force. What is the correct answer? The answer is law of acceleration. Newton's second law of motion. Study the pictures of two different vehicles below. The pictures show acceleration of a large and smaller mass of objects, respectively. The moving truck accelerates at a speed lower than smaller object with smaller mass. Newton's second law of motion pertains to the behavior of objects if the forces are not balanced or if the external net force is not 0. In the presence of a net force, the object will accelerate. Unbalanced force. Newton's second law of motion states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of the object. It is important to note that acceleration of an object is dependent upon the two variables, the net force acting upon the object and the mass of the object. Thus, Acceleration of an object depends directly to the net force acting upon the object, and inversely proportional to the mass of the object. As the net force increases, the object's acceleration also increases. Remember, so, if you push twice as hard, it accelerates twice as much. But there is a twist. Acceleration is inversely related to the mass of an object. In other words, if the object has large mass, there is small acceleration, while object with smaller mass has greater or faster acceleration. The law of action and reaction, Newton's third law of motion. Newton's third law of motion deals with the reaction of a body when a force acts on it. Let body A exerts a force on another body B. Body B reacts against this force and exerts a force on body A. The force exerted by body A on B is the action force, whereas the force exerted by body B on A is called the reaction force. Newton's third law of motion states that, for every action, there is always an equal but opposite. According to this law, the action is always accompanied by a reaction force, and the two forces must always be equal and opposite. Note that action and reaction forces act on different bodies. Newton's third law of motion tells us about the four characteristics of forces. These are: 1. Forces always occur in pairs, action and reaction forces. 2. Action and reaction are equal in magnitude. 3. Action and reaction are opposite in direction. 4. Action and reaction act on Here are some of the situations that deals practically in understanding the third law of motion. 1. Pushing a car. Action force: the man pushes the car. Reaction force: the car pushes the man. When making a push to a car, a force is exerted in a car, whose reaction will push the man directly with the same force but in opposite direction. 2. Hitting a ball. Action force: bat hits the ball. Reaction force: ball hits the bat. We exert an amount of force against the ball using the bat, in which reaction exert the same force towards the bat. This is the reason why wooden bat can break while having contact with the ball being thrown. 3. Deflating balloons. Action force: air inside the balloon rushes down to escape. Reaction force: the balloon moves upward. The air inside rushes down to escape and the balloon moves upward. In this situation, the action is the movement of air out of the balloon. The reaction is the movement of the balloon upward as the result of escape. Like any other quantity, force has a unit and is expressed in Newton, N. 1 Newton is defined as the amount of force required to give a 1 kg mass an acceleration of 1 m per second, or 1 Newton, N, is equal to 1 kg meter per second squared. It is also the acceleration of any object due to gravity. Force is measured by multiplying the mass of an object to its acceleration. The formula is written as Fm times a, where F is force, m is mass of an object, a is acceleration. Sample mathematical problem. Suppose a grocery cart has a mass of 0.45 kilograms is pushed with a force of 90 newtons. What will be the acceleration of the grocery cart? Show your solution using Gressa method. Given, mass equals to 0.45 kilograms, net force equals to 90 N required. A. Equation. A is equal to net force divided by mass. Solution. A equals 90 Newton or 1 kilogram meter per second squared divided by 0.45 kilogram. Answer. A is equal to 200 meter per second squared. Learning task number 2. Use the Gressa method to solve the problem below. Show your solutions. Number 1. What is the mass of the cart with a constant net force of 200 N which is exerted to accelerate from rest to a velocity of 40 meter per second in 10 seconds? A 0.5 kg B 50 kg C 5 kg D 500 kg. Compute first for acceleration before you compute for mass. What is the correct answer? The correct answer is letter B, 50 kg. 2. What is the acceleration of a ball with a mass of 0.40 kg which is being hit with a force of 16 Newton? A 0.4 meter per second squared B 40 meter per second squared C 400 meter per second squared D 4000 meter per second squared. Acceleration is equal to force divided by mass. What is the correct answer? The correct answer is letter A, 0.4 meter per second squared. Number 3. What is the external net force exerted on a 3.5 kilograms papaya, which is being pushed across a table and has an acceleration of 2.2 meter per second squared to the left? A 7.0 newtons to the left, B 7.5 newtons to the right, C 7.7 newtons to the left, D 7.7 newtons to the right. Force is equal to mass times acceleration. What is the correct answer? The correct answer is letter C, 7.7. Number 4. What is the mass of a crate with a net force of 300 newtons and is accelerated at 0.750 meter per second squared? A. 0.4 kilograms, B. 4 kilograms, C. 40 kilograms, D. 400 kilograms. Mass is equal to force divided by acceleration. What is the correct answer? The correct answer is letter D, 400 kilograms. Learning task number 3. Examine picture A and picture B below. Picture B is acted upon by a net force. Answer the guide questions that follows. Guide questions. 1. Which picture shows that the object is at rest? What is the answer? The answer is picture A. 2. Which picture shows that the object is in motion? What is the answer? The answer is picture B. 3. What keeps the object remain at rest? What is the answer? The answer is when there is no outside force acting on it. Or which picture shows that there is external force to be applied in the object? What is the answer? The answer is picture B. 5. What will cause the object to change in its state? What is the answer? The answer is an outside or external force. Learning task number 4. Analyze the given scenarios below. Write the letter that best describes the effect of force in the object in each activity. A force causing an object to A. Start moving, B. Stop moving, C. Change direction. 1. Pushing a cart, causing the cart to move and change direction. 2. Catching a ball, causing the ball to stop. 3. Lifting a sack of rice, the sack still on stop. 4. Steering a moving boat, causing the boat to move and change direction. 5. Throwing darts on a dartboards, causing the dart to move and change direction. 6. Throwing a ball, causing the ball to move and change direction. 7. Running in an oval, causing the man to move and change direction. 8. Braking of a moving car, causing the car to stop. 9. Blowing across rising smoke, causing the smoke to move and change direction. 10. Hitting a baseball with a bat, causing the ball to move and change. The content of this video is mostly from DEP Ed Calibars and Science 8 Learning Module Quarter 1 Week 1, and the GIFs and some pictures are from online sources.